Hello and welcome back at the FinetLink channel. Now we are at the third part of Build a Small Network, and with this material we are ending all the information about the introduction to network. Let's mention once again that the objective of this material is to implement a network design for a small network to include a router, switch, and end devices. By remembering that at the first material we identify the devices used in a small network, we explain how a small network serves as a basic or larger network, and we even use the output of the ping and reset commands to verify connectivity and establish relative network performance. And at the second material, we identify the protocols and applications used in a small network, and we even use host and IOS commands to accurate information about the devices in a network. And now in this third material, we will describe common network troubleshooting methodologies, and we even troubleshoot issue with device in a network. So let's dive in and see those last two topics for the third material of Build a Small Network. In the previous two materials, we learned about some utilities and commands that you can use to help identify problems or errors in your network. There are many ways to troubleshoot a network problem, and you as an administrator, you have to know that the network problems can be simple or complex and can result from a combination of hardware, software, and connectivity issues. Technicians must be able to analyze the problem and determine the cause of the error before they can resolve the network issue. And this process is called troubleshooting. A common and effective troubleshooting methodology is based on these scientific methods. Here in this table, there are shown 6 main steps in the troubleshooting process and the description of each of those steps. First step is that you have to identify the problem. You have to establish a theory of probable causes. You have to test the theory to determine the cause of the problem, and then you have to establish a plan of action and implement the solution. And at the fifth step, you have to verify solution and implement preventive measures. And lastly, and it is more important, is to document findings, actions, and outcomes for the future reference. To access the problem, determine how many devices on the network are experiencing the problem. If there is a problem with one device on the network, start the troubleshooting process at that device. If there is a problem with all devices on the network, start troubleshooting process at the device where all other devices are connected. You should develop a logical and consistent method for diagnosing network problems by eliminating one problem at a time. In some situations, it may not be possible to resolve the problem immediately. A problem should be escalated when it requires a manager decision, some specific expertise, or network access level unavailable to the troubleshooting technician. Let's get an example. After troubleshooting, the technician concludes a router module should be replaced. This problem should be escalated for manager approval. The manager may have to escalate the problem again, as it may require the approval of the financial department before a new model can be purchased. A company policy should clearly state when and how a technician should escalate a problem. One command that is very important when you troubleshoot is the debug command. Operating system processes, protocol, mechanisms, and events generate messages to communicate their status. These messages can provide valuable information when troubleshooting or verifying system operation. The command debug allows the administrator to display these messages in real time for analysis. It is a very important tool for monitoring events on Cisco iOS devices too. All debug commands are entered in privileged access mode. The Cisco iOS allows for narrowing the output of debug to include only the relevant feature or subfeature. This is important because the debugging output is assigned high priority in the CPU process and it can render the system unusable. And for this reason, we use the debug commands only to troubleshoot specific problems. For example, let's see here that we have to monitor the status of Internet Control Message Protocol messages in a Cisco router. And that's why we use the command debug IP Internet Control Message Protocol as it is shown. And to list a brief description of all the debugging commands, we use the command debug followed by a question mark in the privileged access mode at the command line. If you need to turn off a specific debugging feature, we will use no keyword in front of the debug command as it is shown here in this example. In this case, we are turning off the messages from Internet Control Message Protocol. Alternatively, you can even enter the undebug from the command in the privileged access mode as it is shown here. Both of them, they have the same meaning and the same purpose. If you need to turn off all active debug commands at once, you have to enter at the privileged exec mode, privileged exec mode, you have to enter the command undebug all. By caution, because commands such as debug all or debug IP packets generate a substantial amount of output and can use a large portion of system resources. The router could get so busy displaying debug messages that it would not have enough processing power to perform its network function, or even listen to commands to turn off debugging. And for this reason, using this command option is not recommended and should be avoided. It's just for more information for yourself. We have even terminal monitor command, because remember, and once again we are mentioning that the connection to grant access to iOS command line interface can be established in locally by local connection, where you require physical access to router or switch console port using a rollover cable, or remotely, when you can have remote connection requiring the use of telnet or security shell to establish a connection to an IP configured device. Certain iOS messages are automatically displayed on a console connection but not on a remote connection. So, if you use the debug output, is displayed by default on console connection. However, the debug output is not automatically displayed on remote connection. This is because debug messages are log messages which are prevented from being displayed on VTY lines. So, for the output, in this case, the user have to establish a remote connection using telnet from router 2 to router 1, and then the user then issue the debug IP Internet Control Message Protocol command. However, the command will fail to display again the debug output, as it is shown here in the example. As we said, we have to establish a remote connection using telnet from, as you can see, router 2 to router 1. To display log messages on a terminal, which means on a virtual console, we have to use the terminal monitor privilege access command. To stop logging message on a terminal, we use the terminal monitor in the privilege access mode. So let's see if we use the terminal monitor command and it has been entered and the P command display at the debug output as it is shown here. You will see that the intent of the debug command is to capture live output for a short period of time. Always remember you have to disable debug when it is not required. So now let's go and see some troubleshooting scenarios. First of all, remembering the duplex operation and mismatching of those duplex. Many common network problems can be identified and resolved with little effort. Now that you have the tools and process for troubleshooting a network, these topics review some common networking issues that you are likely to find as a network administrator. By remembering that in the data communication, duplex refers to the direction of data transmission between two devices. And we have two duplex communication modes. We have the half duplex communication, where the communication is restricted to exchange of data in one direction at a time. And we have the full duplex communication, where communications is permitted to be sent and received simultaneously. Interconnecting Ethernet interfaces must operate in the same duplex mode for the best communication performance and to avoid inefficiency and latency to the link. The Ethernet auto-negotiation feature facilitates configurations, which means that minimize problems and maximize link performance between two interconnecting Ethernet links. The connected device first announces their supported capabilities and then choose the highest performance mode supported by both ends. For example, the switch and the router in this figure have successfully auto-negotiated the full duplex mode. If one of those two connected devices is operating in full duplex and the other is operating in half duplex, a duplex mismatch occurs. While data communication will occur through a link with a duplex mismatch, link performance will be very poor. Duplex mismatch are typically caused by a misconfiguration interface in a rare instances by a failed auto-negotiation. Duplex mismatch must be difficult to troubleshoot as the communication between devices still occurs. And we have to find even some IP addressing issues. IP address related problems will likely keep remote network devices from communicating. So we are checking the IP addressing issues on iOS devices because the IP addresses are hierarchical, which means that any IP address assigned to a network device must conform to that range of address in that network. Wrongly IP address assigned create a variety of issues, including IP address conflicts and routing problems. Two common causes of an Internet IPv4 assignment are manual assignment mistake or DHCP-related issues. The network administrator often have to manually assign IP address to devices such as servers and routers. If a mistake is made during the assignment, then communication issues with the device are very likely to occur. So on an iOS device, we use the show IP interface or show IP interface commands to verify what IPv4 address are assigned to the network interfaces. For example, by using the show IP interface brief command, at the router 1, we can see the status and how the interface would be validated, even with the IP address. And as for the end devices, in the Windows-based machine, when the device cannot contact a DHCP server, Windows will automatically assign an address for the device. And this feature is called automatic private IP addressing and is designed to facilitate communication with the local network. Think of it, Windows, we said, okay, I will use this address because I could not get any other addresses. Often, a computer with an automatic private IP address will not be able to communicate with other devices in the network because these devices might likely not belong to that range of IP addresses. And this situation indicates an automatic IPv4 address assignment problem that should be fixed. Most end devices are configured to rely on DHCP server for automatic IPv4 addresses assignment. If the device is unable to communicate with the DHCP server, then the server cannot assign an IPv4 address for the specific network and the device will not be able to communicate. To verify the IP address assigned to a Windows-based computer, remember that we use the ipconfig command, and here will be shown even the output of this command. And as you can see, we will be able to verify the IP address, subnet mask, and even the default gateway. And as we mentioned, the default gateway, even for the default gateway, there will be some issues because the default gateway for an end device is the closest network device that can forward traffic to other networks. And if a device has an incorrect or non-existent default gateway address, it will not be able to communicate with the device in remote network. Because the default gateway is the path to remote networks, its address must belong to the same network as the end device. The address of the default gateway can be manually set or obtained from a DHCP server too. Similar to IPv4 addressing issues, default gateway problem can be related to misconfiguration or DHCP problems. To solve misconfiguration default gateway issue, ensure that the device has the correct default gateway configured. If the default address was manually set but is incorrect, simply replace it with the proper address. If the default gateway was automatically set, ensure that the device can communicate with the DHCP server. And it is important to verify that the proper IPv4 address and the subnet mask were configured on the interface of the router and that the interface is active. So to verify the default gateway on a Windows-based computer, we use the ipconfig command as we mentioned before, and as you can see, we will be able to see the default gateway. And if we are on a router, which means on an iOS device, we use the show IP route command to list the routing table and verify that the default gateway known as a default route has been set. And this route is used when the destination address of the packet does not match any other route in its routing table. And it is shown an example where we use show IP route, but mostly it is important which begin with gateway. And the gateway is the last resource for reaching a network. But if we are troubleshooting a network, sometimes we need even to troubleshoot the DNS. Why? Because the domain name system defines an automated service that matches name, such as, for example, www.cisco.com with the IP address. Although the DNS resolution is not critical to device communication, it is very important for the end user. It is common for user to mistakenly relate the operation of internet link to the availability of the DNS, because sometimes they will complain as the network is down or the internet is down, and these are often caused by unreachable DNS server, because while packet routing and all other network services are still operational, DNS failure often lead to the user to the wrong conclusion. And if a user, for example, will type the domain name, the web browser, and the DNS server is unreachable, then the name will not be translated into IP address and the website will not display, so the user will think that the network is down. The DNS server can be manually or automatically assigned. For manually configuring that, it is responsibility of the network administrator, who has to assign the DNS server address on a server and other devices, while for the DHCP is used to automatically assign DNS server address to the clients. Although it is common for companies and organizations to manage their own DNS server, an unreachable DNS server can be used to resolve names. Small office and home office users or SOHO users often rely on the DNS server maintained by the Internet Service Provider for name resolution. Internet Service Provider maintained DNS servers are assigned to SOHO customer by using the DHCP. Additionally, Google maintains a public DNS server that can be used by any, and it is very useful for testing. Cisco offers OpenDNS, which provides secure DNS service by filtering phishing and some malware sites. You can change your DNS server in the preferred DNS server and alternate DNS server fields. Advanced features such as web contact filtering and security are available to families and business. By using the command ipconfig/all, you will be able to verify which DNS server is used by the Windows computer. And if we use the NS lookup command, is another useful DNS troubleshooting tool for computers, where the user can manually place DNS query and analyze the DNS response. The NS lookup command shows the output for a query, and if you can see here in this example, you can simply enter an IP address and the NS lookup will resolve the name. And with this, we are ending all the information about the third part of the Build a Small Network. Thank you for being with us. See you in the next session. And if you like the video, share it with your friends. And if you are new to this channel, hit the subscribe and hit the notification button for the new videos that will be uploaded. And with this material, we are adding all the information about the module of the CCNA Introduction to the Network. See you soon.